Okay, business algebra. Chapter 3 starts with some basics before we move on to some algebra. So we start with functions. Some general facts about functions is a set of ordered pairs is called a relation. It has to satisfy certain conditions to be a function, where for every input there's exactly one output. So basically you're looking to see if an input, which is the first number in the ordered pair, there's two of the same inputs with two different outputs. So if you look and you see none of the same inputs at all, then it's automatically C is a function. It's automatically a function. The only time it can really trip you up is if you have the same input twice with two different outcomes. So let's look at table B. Here's some x values, which are inputs, and y values, which are outputs. And you notice here 2 is going to -1, and here 2 is going to -7. This is what it looks like when it has the same input going to two different outputs. This would be 2, -1, and 2, -7 if it were in the form in part A. Does this table represent a function? No, because you have the same input going to two different outputs. And even if something is not a function, can it still be a relation? Yes, any set of ordered pairs is a relation. For example, table B is still a relation, but it's not a function. Okay, so what are some properties in functions that are important? We have domain, which is to collect all the possible input values for a relation, and range, which is the possible output values. If it's a discrete function, which is just sets of ordered pairs as opposed to like a function down here in function notation, then you will have individual items in the domain and range instead of a range of possible values. So looking at B, determine if it's a function and find the corresponding domain and range. You see here we have a 7, 4 and a 7, 3, so it's not a function. The domain is all the input values. Now we use these braces to separate single values. So when you have just a set of points, you'll use the braces. So what are some of the inputs we see? We see 5, 7, 9, and -2. And the order really doesn't matter. You can put them in ascending order if you want. And the repeating 7, we don't need to mark it again. Some of the output values, we see 3, 4, 6, and 1. So even if it's not a function, it still has a domain and range. Let's look at B. B can be kind of tricky for whether or not it's a function, because you do see the same input twice. However, it's going to the same output, so that can be kind of tricky. As long as it's going to the same output, the repeat doesn't matter. Only if they're going to different outputs doesn't matter. This is yes, it's a function as far as we can tell. The domain, all the input values we see 2, 4, and 6. The range, so all the output values, which is just -1. Now, sometimes finding your domain is a little trickier from functions. To find the domain of the following, f of x equals the square root of -x plus 3. So what do we know about the square root? Numbers under the square root need to be greater than or equal to 0 for our purposes, which means now I would just have to solve for x to see what numbers I can put in for x, my input values, in order to not get a negative under the square root. subtract 3. Negative x is greater than or equal to negative 3. Divide by negative 1, and just remember when you divide or multiply by a negative, the direction of the inequality changes. So x is less than or equal to 3. This would be our inequality notation. If you want interval notation, that means all the numbers that are less than 3. And so an equal to sign means we go up to 3. All the numbers less than 3 go down forever, and we use negative infinity to represent that. So these are two different ways to represent the same thing. This is inequality notation. This is interval notation. Most of your homework will require you to put it in interval notation. Now, what about f of x equals 2 over x minus 5 plus 3? Should be no problems here for our domain, except we cannot divide by 0. Which means x minus 5 can't be 0. And if we add 5 to the other side, it means x can't be 5. So x could be any number except 5. Which means it can go all the way down to negative infinity, all the way up to positive infinity. It just needs to jump 5. So the way we do that in inequality notation is we start at negative infinity. The infinities always get parentheses, as you're never going to actually get to them. They're concepts, not numbers, until we get to 5. We can't include 5. And then from there, we jump over 5. And the way we do this is we start on the other side of 5 and go all the way to positive infinity. This here means the union. It means everything on this side and everything on this side as well, put together in one group. Now, most people seem to find it easier to determine if something's a function from a graph. Because even though you may not remember how to do that, you can determine if a relation, the graph of a relation, is a function using your old friend, the vertical line test. And I think most of you actually have heard of the vertical line test, even if you don't remember or it's been a while. So we have the equation y equals x, which is a diagonal line through the origin, if I can draw properly. Now, is this thing going to pass the vertical line test? That means if I drop a vertical line anywhere, is it only going to touch the function at most one time? It looks like yes, and generally for linears, it is true. It passes the vertical line test, so it is a function. X equals negative y squared. Y equals x squared is an upward parabola, and negative y squared is a downward parabola. X equals y squareds are a little different. They're to the right or to the left. This one happens to be a leftward parabola because that's the negative direction for x. So let me draw this as best I can. And what you notice is if you drop a vertical line here, is there anywhere it can touch the function or the relation twice? Yeah, pretty much anything on the left side is going to touch the relation twice. So this one doesn't pass the vertical line test. Not a function. And lastly, y equals x squared is our normal upward facing parabola. And if you drop a vertical line, in this case, anywhere, it should only touch once. Even though this looks like it gets almost vertical, it never quite gets there. So this passes the vertical line test. So it is a function. And we will continue 3.1 in the next video.